please help me to welcome John. He's going to talk about the future of printing for enterprise and its desktop.
Right.
Excellent.
Thank you, Chris. Good morning. So I'm going to spend about 20 minutes talking about desktop 3D printing. And a lot of people think about desktop 3D printing as it's really first starting about 5 or 6 years ago, primarily for makers and hobbyists and fab labs and some schools. But I think what I'd like to leave with you today is some examples of how this is really starting to move much more aggressively into the enterprise, and how people are using printers, which everybody thought were for their kids or for hobbyists, but are being used in a professional environment much more so here in 2017. So just a little bit about, a quick commercial about Ultimaker. We're one of the leading desktop 3D printing companies. There's lots of ways to people define desktop, but in a lot of ways people define it by just price, being about below $5,000. We've got over 70,000 printers installed over the last couple of years. We believe that's sort of one of the bigger numbers out there in the industry. Ultimaker is a Dutch company, so our headquarters and the large majority of our folks are in the Netherlands, just south of Amsterdam. But we set up sort of a more substantial US operation here over the last couple of years. Headquarters here in the Boston area in Cambridge. We have an office in New York, and then a manufacturing, distribution, and service center in Memphis, Tennessee. Just really quick about what we sell, and we do have a stand outside, so I'd welcome people to come by and see some of the things we have. But our product lineup goes from anything from $1,000 all the way up to about $4,300. The majority of our customers these days are buying systems, the Ultimaker 2 Plus and the Ultimaker 3, which gives a whole range of capability for a variety of applications. We also have a software platform called Cura. And Cura is 3D printing software. We often call ourselves the curators, or the sort of shepherds of Cura. Cura is open source, and so we develop the product. We have the community have added to that product over time, and I think it's really helped to move this product and this ecosystem along at a much faster pace than I think this industry has moved in a number of years. We also sell a range of material. So PLA, ABS, polycarbonate, polypropylene, nylon. And this is also one of the reasons why desktop 3D printing has started to move into more significant engineering applications over the last couple of years. So let me talk a little bit about this progression. So a lot of people, desktop 3D printing 4 or 5 years ago started like this. This was the customer. It was the guy in his basement, the guy in his garage. The machine's made out of wood. That was the state of desktop 3D printing when it first started. It was a great thing because for the first time it was accessible. It was at low price. It was a couple $1,000s. People could really get into this. A big deal. Really a way to sort of jumpstart this industry, this segment of 3D printing. And they were printing stuff like this. So fun things. A really good way for this technology to move down into a much wider base of people. But what has been happening over the last few years, some of it's Ultimaker, but many of it's a number of our competitors, is what we often refer to as the convergence of capability. So you had this big gap between industrial 3D printers, very, very capable, what we call high capability, but relatively expensive, relatively fixed, not open in terms of either open source or open platform in terms of materials. And then you had standalone desktop printers that you go back a few years ago, low price, not a lot of capability. You could do some basic stuff. But over time, what's happened over the last couple of years is that capability of those desktop 3D printers has been rising pretty quickly. We almost see it quarter over quarter, with new materials, new software, more reliable machines. And now we're seeing that companies are bringing in not just one, they buy one, and then they buy two, and then they buy 10, and then they buy 20, and it becomes part of their engineering environment. I worked for a robotics company in 2013-14. So I was a CEO of a small robotics startup, and I knew a lot about 3D printing. I've been in this industry for a long time and been out of it for a couple years. And one of our engineers says, we should get one of these desktop 3D printers. So this was 2013, 2014. And I was like, no way. It's not good enough. let's get something else. We were actually using a Stratasys machine. And that was the state of the industry. And I think what I'll describe to you today is how quickly this is moving to sort of converge on the capability that people need. So I'll pick on one of our competitors here and sort of compare desktop 3D printers with a platform from another company. And I think where this was back 5, 6, 7 years ago is on most marks, a desktop 3D printer was not very reliable, quality wasn't very good, cost was low, that was nice, but all the other things were not very good. And therefore, I think my assessment in 2013, 2014 was probably pretty correct for most professional environments. But what has happened over the years in 2013 now into 2017 is those boxes are starting to get checked in terms of reliability, performance, range of materials, the skill that people need to run them. This has all evolved, again, very quickly. So now, I go back to this. This was the customer, let's say in 2012. This is the customer environment today. So very much a professional work environment, a design group, an engineering lab with multiple engineers and multiple printers, to even this. So we're starting to see this. We'd like to say that Ultimaker was the ones out there with this idea and pushing it. It didn't happen this way. We had customers buying 1, 2, 3, 5, and then all of a sudden we're like, they have 50 machines. Like, what are they doing with 50 machines? And I think a lot of our customers dragged us into this conversation. And it's the same analogy as a supercomputer versus sort of servers and server farms. You get all the advantages of parallel processing, all the advantages of redundancy. If you can think about it, you can print 20 different materials at the same time. And so this is the world we're living in right now. It's pretty exciting. And in a lot of ways, our customers are pulling us along as a company. They ask us, how do we integrate this with our ERP systems? And we don't know. That's not what we're good at. But what we see is our customers are pulling us in this direction and helping us find solution for a much wider range of customers. Going to give you a little insight about how we think strategically about the market. And we have our place. We're a desktop 3D printer company. I think we have big aspirations about where desktop 3D printing can go. I think we're also realistic about where desktop 3D printing probably won't go in the next couple of years, and maybe some other companies in additive manufacturing will go. So when we think about this, we look at a typical product lifestyle where 3D printing really fits in, early stage concept models, visual prototypes, functional parts. There's been a lot of discussions over the years about over the recent years, last year or two, about additive manufacturing and 3D printing in production. That's exciting, but I think people tend to forget that the killer app still for today for 3D printing is the prototype. The fact that you can have a machine in your office and have a part in a couple hours, that's still the killer app. And so that's still extremely valuable where 3D printing fits in. But when we look at the whole product life cycle and where desktop 3D printing comes in, we actually are realistic with ourselves, and we don't think we can necessarily play here in mass production. In factories with big equipment, high volume, high performance, we're not sure desktop 3D printing can really fit in there. There's a lot of other technologies here that I think are making a run at that, which will be pretty exciting. But where we think desktop 3D printing could also come in is in some of these other areas in terms of low volume, jigs and fixtures and tools, production, but also at the back end. Spare parts, obsolete part creation. And you think about how most products are produced in a factory with infrastructure and people and the cost structure to support big equipment. But most of the service and aftermarket is not done there. So you think about automotive, there's big automotive companies have 10, maybe 10 factories around the world. They have thousands of repair centers. So having a $1 million machine won't work in a repair center, but maybe having printers that are $5,000 or $10,000 would very much work in a repair center. So this is how we think about the world, and where we think desktop printing can play over the next couple years. And we're conceding this. We think some of the other companies out there who are working on some exciting things in additive manufacturing could very much play a part in mass production. So to give you a couple examples of where desktop has moved, I'll give a couple examples to end the presentation. One is Robotics, a company called, most people know ABB. and they have a robotics product line. And this category of robotics, often called collaborative robotics, is sort of this move from big industrial robotics in a cage to robotics that can interact with people. So ABB has their own version. There's a company called Universal. There's a company here in Boston called Rethink Robotics. And really the value of these types of systems is they're easy to program, easy to work with, they're safe. But one of the tricks about robotic systems is they almost always need a gripper or an end effector to pick something up. And sometimes in some factories, you're doing the same thing millions of times over and over and over again, so you have one gripper or end effector. But I think a lot of the idea behind collaborative robots is you want the flexibility to do lots of different things in a factory, so you need lots of different end effectors and grippers. And that's an end effector, so it's a little gripper to pick something up. Well, the challenge there is you need a lot of them. And they break, they fall on the floor, somebody steals them, who knows? This is very much like a consumable item, and so 3D printing is perfect for this. So this was a great application where a 3D printer could essentially be placed alongside a collaborative robot and be able to print end effectors as much as you want. And the price makes sense, because these robots typically cost $20,000, $30,000, $40,000, $50,000. So a $2,000 or $3,000 3D printer right next to it makes a lot of sense. Sort of a no-brainer for lots of companies. Second example, so ABB is a big company. Here's another one called Snow Business, small company. They make, you might be able to get, they make snow machines. So snow machines for movies, for festivals. As exciting as that is, it's not a huge market. So they're very specialized, and they're always customizing their product for different customers. And they had historically used CNC machining. They used service bureaus, primarily for a number of parts in the snow machine, for prototyping different things. And they just decided, we should just do this ourselves. We should just make these parts ourselves. We're a small company, so we don't want to buy a $100,000 printer. We need something that we can run, that we can build and have in our shop. So they bought a handful of Ultimakers, and they use it for prototyping, but they also use it for a number of the end-use parts that they actually use on the snow machine. So these are the nozzles. They're actually made in nylon, and they use these all the time, and now it's a standard part of their production process. And you can see the difference. So for 3D printing in general, what the value that 3D printing brings over service bureaus, over traditional manufacturing techniques, is really all about cost and time. So previously, it would cost them over $100 to get an SLS part made. Now it costs them, this is actually in pounds, this is a UK company, only a couple bucks. Previously, it would take them about a week to get the part back. Now it takes them about a day. So those are the advantages in this situation of just using in-house desktop 3D printing. So the last one I'll talk about is Volkswagen. So Volkswagen actually currently is the largest manufacturer of cars in the world. And they, if you can imagine, they have very sophisticated manufacturing facilities. They have all the tools that you could ever imagine. Probably everybody here in the room has maybe sold something to Volkswagen in their history. So they buy a lot of stuff, software, simulation, 3D printers. And one of their factories in Europe was very much looking at what some people forget, but is a pretty important part of manufacturing, are just jigs and fixtures and tools in the basic assembly of an automobile. And so this, for example, is a fixture and a jig for actually putting the windshield on the car. So there's a lot of automated processes, but there's also lots of manual processes using these jigs and fixtures and tools. This is just a part for sort of mounting the wheel. So a very relatively simple part, but they've used this for years. They've always either gone out and used a service bureau to this, got parts CNC'd, or used a more expensive 3D printing process. And again, big savings. They used to spend close to $1,000 with external suppliers versus $20 for the one part when they're printing it in-house. Same thing. Instead of close to 2 months, they can get the whole thing done in less than 2 weeks. I always think about this one because a lot of times I don't think about how things are made, but most of us have a car, and most of us have a car with the name of the car is on the back of the car somewhere. It's on the trunk or it's on the hood. And I never knew really how cars are made. You figure somebody just puts a sticker on there, puts the badge on there. Well, they need a fixture for this. And so this is basically just the jig that they put on the back of the car, and now they can put the label on. And so it's simple things that they need for building cars. Again, the liftgate badge, big difference in terms of cost per part, big difference in terms of what it took for them to develop that part. And I think the big thing with things like jigs and fixtures and tools is they need them all the time. They don't need them once. They need them all the time. They break, they change, they get lost, they fall onto the car. They need to make them all the time, and they needed this capability. So in this case, Volkswagen brought in, it was about 20 Ultimaker 3D printers, and they just consistently build these jigs and fixtures and tools for their production process. So the last thing I'll leave with everyone here is again, how we think about our business, how we think about Ultimaker exists and the value we're providing to customers. And I just really leave with two words. It's really about cost and access. People often ask us or me, what do I think the biggest innovation is in 3D printing over the last couple years? And there's been a lot of stuff, a lot of great technology that's been developed, but a lot of it is really around the core idea that it's reducing cost and it's increasing access. I mean, that's the game. And so when you think about other companies, the HP multi-jet fusion process, that's about cost. I mean, they make great nylon parts today. They'll make maybe other parts in the future, but at least today, it's about speed and cost. That's the innovation. You look at Formlabs. Formlabs is now offering great SLA parts, sort of like SLA parts, pretty close, for a fraction of the price of traditional SLA. That's the disruption. It's about cost. You look at desktop 3D printing. It's about cost. I mean, we're now approaching what other people can do in terms of quality, but it's about cost and access. My friend Rick Fulp will stand up here and talk about metal. Same thing. It's about desktop metal is about offering metal parts at a fraction of the cost and a fraction of the time that you used to be able to get. So people often think about the technology piece of it, like, oh, I can now do this metal, or I can now do this plastic, or now I can get this accuracy. Most of the technologies can get to those points now in terms of what's required by the customer. But now the game is about cost and access, and that's how we think about our business. Thank you.